Hi everyone, the last and the third profile in this lecture series is about the laminar flow over a plate. So this is a laminar flow over a plate. This is single plate, and moreover this is like we have the free surface on the top of it, and it is similar to the flow between two parallel plates, but only difference that this is almost like a half profile. Okay, so and from the equation point of view, you can see the difference is that because of the half, we have the y upon 2h and y upon 2h whole square. This is the only difference. Okay, so I will start from the picture. So let me draw it. So the difference here is that we have the one plate on the bottom, and on the top, instead of the some fixed surface or rigid wall, we have a free surface. So the velocity profile is like a half of the parabolic profile, and it is almost similar to, not similar to, but something like a flow over a flat plate, but it's not exactly same. So we have the velocities varying in this way. Okay, so height is h, same height, and so the coordinate system is placed also here similarly like the last case, and we have the xy coordinates. And one more thing is that boundary condition are concerned. So at y is equal to 0, we have the two things, u is equal to 0, and so at the y 0, u is 0. This is the one condition, but at the y is equal to h, we have that the velocity is u is equal to u max. This is the one thing. And second thing is that at y is equal to h, the du by dy is equal to 0. Okay, so I will start from the previous case equation with the constants. That is the 1 upon 2 mu dp by dx, and y square plus y and c1 plus c2. So only difference from the previous case is basically is in terms of the these constants. So because they depend on boundary conditions are slightly different. So definitely they are going to be different. So first of all, if I apply the first boundary condition, that u is equal to 0 at y is equal to 0. So this term is 0, this term is 0, and this term is 0. So C2 is equal to 0. Now as far as du by dx, du by dy is concerned, so we have this is equal to 1 upon, so this will be the 1 upon mu, because the 2 will be cancelled out from the y square. So this is 2y, so this 2 mu, so the 2 will be cancelled. So we have 1 upon mu and dp by dx into y plus c1. Okay, now we know that the du by dy is equal to 0 at y is equal to h. So 0 is equal to 1 upon mu dp by dx, and here y is h. In the previous case, this was equal to y by 2, h by 2, and c1. So from here we can find out that the c1 is equal to minus 1 upon mu dp by dx and h. Okay, so now we can write down the u is equal to, because this is c1, c2 is equal to 0. So I can write down the u as a 1 upon mu and dp by dx and y square upon 2 minus hy. So you can simplify this equation in this way. So just put the value of c1 in u. So c1, c2 is 0. So you can find out this equation. Okay, so now we have this thing, and at y is equal to h, the u is equal to u max. So the u max is equal to 1 upon mu, is equal to 1 upon mu and dp by dx. This will be the h square upon 2 minus h square. So therefore 1 upon 2 minus 1 is equal to minus 1 upon 2. So this is equal to minus 1 upon 2 mu, but you can write down this thing as a h, and so this will be h square dp by dx. This is the value of u max. So now we know that the u is equal to this value. So u is equal to 1 upon mu dp by dx, and this is the y square upon 2 minus hy. So I can write down this equation in, so this is the u. So I can write down this equation in this way. So basically I can write down this equation as equal to 2. So this 2 means that I have to divide this also by the 2. So this will be 1 upon 2 mu. And also I want to take out the minus sign common. So this will be the minus sign common is also taken, and also I want to take the h square common. So this will be the minus h square upon 2 mu. So if I take minus sign common, and here dp by dx will be same. So if I take the h square and minus sign common, this will be equal to y upon h. And this will be equal to y square upon 2 h square. Okay, so if I take this thing inside, this 2 inside, this will be so just wait. So this will be exactly equal to the same thing. So y square upon 2h. Just a minute. So basically what we want here is u maximum is this thing. Okay. So u maximum is this thing. So we can write down this thing as 2 u max and y by h minus y square upon 2h square. Okay, so now the only one last step. So I will also take the 2 common, or in simple words, divide by 2 and multiply by 2. So if we divide by 2 and multiply by 2, so 2 to the will be 4, and here is u maximum, and by dividing it means that this will be y by 2h minus y square upon 4h square. So we can write down this thing as 4 u max. This is square bracket and y upon 2h minus y upon 2h whole square. Okay, and also keep this thing in mind that the u maximum is equal to minus h square upon 2 mu dp by dx. Okay, and now we need to find out the u mean. So u mean would be equal to q upon area. All right, so this q will be equal to 0 to h, and then we have to multiply with u into dA. So the dA for the a small element would be equal to dy into 1. Okay, so and divided by area, so area would be equal to, the simple area would be equal to h into 1 is equal to h. This is dy. So this is equal to h. So the u, we know this u is equal to the u in the very original form. This u is this one. So 1 upon mu. So 1 upon mu and dp by dx and dp by dx y square upon 2 minus hy. Okay, so 0 to h and dy divided by h, so it's 1 upon h. So now I can write down this thing as 1 upon h and also take out the 1 upon mu and dp by dx common and now integrate. So this integration would be y cube upon 6 minus h y square upon 2 and limits are 0 to h. So we have 1 upon h, 1 upon mu dp by dx. So this is equal to y cube upon 6 minus, so y cube will be h cube upon 6 and this is also h cube upon 2. So 1 upon 6 minus 1 upon 2. So 6 is the LCM, so 1 minus 3 minus 2 upon 6 is 1 upon 3. So this is, and you know this is h power 3, so 1 h is here, this will be h square. So we have minus 1 upon 3, this will be minus h square upon mu dp by dx and here will be 3. So we have u maximum is equal to minus h square upon 2 mu. Okay, so it means that u max upon u mean is equal to minus h square upon 2 mu dp by dx and divided by minus h square upon 3 mu dp by dx. If you cancel out, so we have 3 by 2. So u max is equal to 3 by 2 u mean, and we derive that the u is equal to, this u is equal to 4 times u max. Okay, so u is equal to 4 times u max, bracket start y upon 2h minus y upon 2h whole square, bracket close. So this is 4 into 3 by 2 u mean and y upon 2h minus y upon 2h whole square. So this is equal to 6. So 6 u mean into y upon 2h minus y upon 2h whole square. Okay, so this is the velocity profile when we have the channel length is equal to h. Okay, so now we have derived all 3 profiles. One is for the laminar flow in a pipe, then laminar flow in a closed channel, and third one is the laminar flow in an open channel.